Well, let's consider the step function u2 t squared minus t, and this is the step function that we want to consider, and we want to find the Laplace transform of this function, right? This step function, and you can see that this is step functions where the step units is 2, and the functions is t squared minus t. All right. Now keep in mind that in Laplace transform of step functions, we have two different forms. So the first form is the Laplace transform of uc, where c is a unit step, f of t minus t equals to e to the negative cs multiplied by big F of s, where big F of s is the Laplace transform of f of t. This is the f of t. So again, big F of s here is a Laplace transform for the functions f of t, where you find that this is the function f of t minus c. And c is the unit step, all right? Or you can use a different form, different formula, which is the Laplace transform of the step function uc f of t, again just f of t, equals to e to the negative c times s, multiplied by g of s, where g of s is a Laplace transform of the function f of t plus c. So you have to find the Laplace transform of f of t, and then you have to find the Laplace transform of f of t and plus c, where t plus c is the input of the function. Keep that in mind. All right. So we have to, before we can find the Laplace transform of a unit step, a step function, you need to put it in the correct form. So consider this functions right here. The correct form for this function should be, you can see that this is a function t squared and this is a function t, right? F of t equals to t squared, f of t equals to t. Then the correct form should be u2, where 2 is a unit step unit, and the function t squared has to be t minus 2 squared. And u of 2, where 2, again, 2 is the step unit. And then the function f of t has to be t minus 2, because 2 here is the step units. You have c here and you have c here, SR. So we know that we have to put this in the correct form, where the function f of t, t squared, if the function f of t is t squared, then f of t minus 2 has to be t minus 2 squared. And if the function f of t equals to t, then f of t minus 2 has to be t minus 2. All right? Now, look at our functions. We have t squared minus t. And again, we want to put it in the correct form when we have t minus 2 squared. So we'll put it there. So this is the goal. And then we know that t minus 2 squared is t squared minus 4t plus 4, right? But in the original function, we only have negative t. We don't have negative 4t. We don't have plus 4. So we have to do some algebra manipulations in order to reserve the original function. So now we have negative 4t. How can we have negative t? We add 3t. So 3t minus 4t is negative t. Okay, we reserve it. We reserve the negative t term in the original functions. But then again, in order to find the Laplace transform, we have to put in the correct form, and the correct form has to be t minus 2. So we put t minus 2 multiplied by 3 in parentheses. And then 3 times t minus 2 becomes 3t minus 6. All right, so now keep in mind, we have t squared minus 4t plus 4 plus 3t plus minus 6. We have to do something in order to reserve the original function. So t squared, it's just t squared, good. Negative 4t plus 3t is negative 3, which is good. Then that's it. We don't have any constants. But now we have plus 4 and negative 6. We have, and which is 4 minus 6 is negative 2. We have to add to 2 in order to make it 0. All right. If you do your algebra, you will see that this form, this expression here, is exactly t squared minus t. But I put it in the correct form, t minus 2 squared, t minus 2, and this is the constant. So then we can find the Laplace transform using the first form that I showed above previously. Okay, so Now the function is u2t, t squared, t minus 2 squared in the good form, 3 t minus 2 in the correct form, and 2 is a constant. We know how to find the Laplace transform of a constant in terms of unit function. So, all right. Then I can split this unit function into 3 different functions. So then I can show you how to find the Laplace transform for each of the functions. We know the functions, we know c is 2. And we know this function f of t is t squared. So then the Laplace transform of t squared is 2 over s cubed. This is the Laplace transform of t squared. Okay. So then we get e to the negative 2s multiplied by 2 times 2 divided by s cubed. And then go to the next function. We know that the function f of t is t. And we know that the Laplace transform of t is 1 over s squared. Okay. Then we put it, and then the next function is just a constant. And we know that the Laplace transform of a unit step function is just 1 over s. Multiplied by 2 as the coefficient. So the final answer for this question is this expressions right here, e to the negative 2s, because we have a unit functions where the step unit is 2 multiplied by big F of s, right, plus 3 e to the negative 2s multiplied by 1 over s squared plus 2 times 1 over s. So my suggestion for you is when you have a step function and you want to find a Laplace transform of a step function, you need to put it in the correct form first before trying to find it. Or you can use the second form right here to find the unit step functions, right? You can use it, you can use UC of f of t, and then you have to find the Laplace transform for the f of t in terms of t plus c, either ways. But you have to put it in one of the correct forms. You have to use one of the correct forms in order to find the Laplace transform of step functions.